All right, so it's 1 o'clock, so I guess we'll go ahead and get started here. It's after lunch, I understand. You're going to be tired. It's the last day of the summit. Your brain hurts. That's fine. So thank you for coming out here. So I'm going to be talking about piping data between packaged PowerShell scripts, or in other words, inter-process communications with packaged scripts. Something that maybe sounds a little bit more developer-y than you're used to, especially if you're dealing with your PowerShell files, your PS1s and everything. But I think it will be useful. I found a few applications myself where it's useful. But that being said, who I am. My name is Paul DeArment Jr. The junior is important. If you Google my name, you'll either get my dad, my half-brother who's half Vietnamese, or me. We're not very original with names in my family, apparently, since we're all Paul DeArment. So by day job, I'm a system engineer for Advocate Aurora Healthcare. I was brought in to do automation across their enterprise, especially now that we're merging with another hospital company. It's become very apparent that we need to do that a lot more. And outside of that, though, I do have other hats I wear. I'm a podcast producer and co-host. I mentor teens. I play bass guitar. I'm just busy all the time. So, I really spend a lot of time in PowerShell and as my day job, and I don't have time outside of that to really sit there and invest and be like, how can I do all these creative solutions to do something that, I see other people doing? I am also the co-leader of the Milwaukee PowerShell user group, and my cohorts are here at the conference as well this year, which is nice, and we're celebrating our 1-year anniversary this year. We started up just after Summit of last year. I am part of the Battle faction, and I hope that all of you will at least stay and watch Iron Scripter coming up. It's a lot of fun. If not, if you don't want to join in, at least watch. And I am available via Twitter and email address as well. So, what we're going to talk about today. What is inter-process communication? Again, if you're doing a lot of PowerShell stuff, if you're not a developer, this might be something that's new, something you might not understand why you would want to use this. And why are we using this at all? So I'll bring up an application, and please do not spam my help desk for my work. They will kill me. And if PowerPoint would die. There we go. So this is a utility that they currently use at my work. And what it is it's an application that is on all of our endpoints for all of our nurses, our doctors, and that. So that way, when they call a service desk technician isn't walking them through, well, what's your IP address? They just have a button they can press. If you've ever worked on the service desk trying to walk a nurse through, okay, go to the command prompt, type IP config, no, not I, none of that has to happen. So we have this little tool. Well, one of the functions we added recently here was this add printer utility. In our environment, how we have printing set up is that a printer group is added to the computer account, and that's how printing is done. That way, whatever nurse or doctor is working at, like, say, an OR, they always have access to the same printers. They don't accidentally print to their other facilities. And what we encountered was some problems with this because obviously we don't want to give nurse accounts and doctor accounts access to change AD. That would be just ludicrous. Security people would kill us, skin us alive. So what we did was we created a service account that has access to it, and when they press this button, this add printer button, it executes another executable that's embedded inside of here that then runs and returns the status back of it, was it successful or not. Now obviously, we don't want our doctors or nurses to have to go through log files, see things. We want to be able to present a message back to them on the screen saying, hey, this was successful, this wasn't successful, here's the error message of what wasn't successful, so our support desk knows what to do next. And that's how this whole process of us kind of at our company working through how to do this and discovering, honestly, it's kind of simple once you get the hang of it. So, once this comes back up, of course it has to do that. So what is inter-process communication? It's really just sharing data between processes. And it can typically involve a client and a server. And this comes up when you're dealing with like sockets, network pipes, named network pipes specifically. And the one thing you gotta remember is that a client or a server, they can be both. It doesn't have to be just one direction. You can send data back and forth. And there are multiple ways that this can be done. We can do this through a memory mapped file, which is available through .NET, so .NET Core. Pipes, anonymous pipes, named pipes. Something that we've always done, files, that's technically a way you could do inter-process communication. Sockets, and there's many more. On the link provided here at the bottom, there's a link on the slide deck with multiple other ways that you can do inter-process communications and many other methods. Some of it depends on your OS. A lot of it needs to be supported by your operating system, but in all honesty, 99% of these are supported by most major operating systems these days. So again, I showed you kind of why we would use an inter-process communication. When you need an executable that runs as a different account, a service account. Okay. When that service account needs to run and send data back and forth in a nice readable format, and especially since a lot of us are using PowerShell, we like objects. I don't know about you, but I don't want to go back to the old days of parsing text on a command line. That just isn't fun for me. So let's go ahead and take a look at some of this here. Jump over to after my PowerPoint decides to kill itself. There we go. Oh, thought I had that open. There, I think maybe my mouse was. Yeah, the demo gods really do not like me today. Hey, success. All right. So I have my little script here. All right, I just need to set up. That. I swear it was working before here. Okay. There we go. Okay. So I just need to create a credential here. All right. Load in my support functions. All right, cool. My support functions are in there. So how we're used to working with stuff in PowerShell is we're used to doing stuff like invoke command or running a command that has a computer name parameter. So that way we can go out, reach another computer, grab that data, pull it back, work with it, and work with our objects. Simple everyday thing, first day thing that you kind of learn when you start delving into PowerShell. And what we like always is that it is a full object. We have that data back. We can delve further into some of these properties. There's methods available. If we notice, this is a deserialized object. So what that means is when we did the invoke command, it actually serialized it before transporting it over WinRM, brought it back, converted it back to an object for us. All right, cool. That's not useful for us right now in that form, but it's good to know that that happens. Now, when you start dealing with executables, your life starts getting a little bit crazier. And this is true for both of the main packaging utilities I use. Sapiens PowerShell Studio as well as PowerShell Pro Tools, they can both package scripts as executables. They both take input and provide output. Okay, it looks like exactly what we were looking at before, but they're only strings. So unless you want to sit here and convert all your strings over to objects every time, or you just want someone to read the log and not take any action on these objects, that's fine. But if you want to go further in, you want to investigate further, you have to convert this to an object. Well, the problem is then, if you want to do that, you'll need to open up your file, your executable. You need to open up your caller command. And obviously, you're going to have to update all your pester tests because you're doing pester testing on all your production stuff, right? Exactly. There's no tests here because this was, I'm not going to do tests for a demo here. for this, and I'm showing you exactly what not to do and what Battle would do. All this executable is doing that I have running here is just doing a simple get process. That's it. So if I wanted this to include more properties, I'd have to open this up, add what I want after get process. Then I would have to rebuild the executable after I rerun all my tests, go back to my caller, re-update that. And so I can, like I said, I can convert this over to an object, but it's very limited on what I get back. It's only what is available through that executable to begin with. Not too useful. It's useful if you just want the basics, but beyond that, okay, fine. Now, at least we're getting something. Now, if we have an executable that runs as a different account, in case you didn't see that, all it does real quick is it opens up as a whole other executable. Now, when it does that, unfortunately, PowerShell doesn't know how to redirect that output by natively. And you got nothing. So all of a sudden, your service account that is modifying AD, if you're not having it log out, and even if you are having it log out, you don't want your nurses to have to go read a log, you have no idea what happened. Was it successful? Was it not? How do I go and test that? How do I get that message back? And so this is where that inter-process communication comes in. And this is where you can do a few things to kind of help yourself with that. So the first one that I mentioned is temporary files. Who likes working with temporary files? I know I don't. I don't like having to worry about, will my names collide on my temporary files? Where am I placing them? Do I have the correct permissions? Cleaning them up afterwards so I'm not littering everywhere. I like to be a good citizen when I'm dealing with stuff, especially for my clients. Leaving just files everywhere, they're gonna, eventually be annoyed. So Microsoft does have the built-in ability to do stuff like export CLI XML. Nothing crazy with that. It's just the standard XML file that no one would ever in their right mind build by hand, because their version of that is just disastrously horrible. But it works nice in that it's able to transport that object whole across processes. So here I have PowerShell Core 6. And if I can type, that'd be great. All right. And if I bring that data in, notice we get our object again. Again, I'm just doing something simple with get process. This can be with a custom object you make, anything complex that's out there, whether it be PowerCLI or any other thing that you need to do this with. So then if we look at this, we notice again, we have a fully deserialized object again. We can drill down through the properties, use the methods, do everything that we were doing before. Again, just a different way to get that data back and forth between. All right, so that's simple. And I know some of you are probably gonna go, why are you using JSON? Why are you not using JSON? Because JSON is kind of like the popular thing right now. Everything and everyone wants to use JSON. You can use JSON. You do lose some of the object when you bring it back from JSON. So if you don't care about that, if you just want some of your data and that data in there is actionable that you can work with, that's fine. Use what you want to use to do that with. It looks a little bit ugly, but it's all there. Yep, you lose some. Now, some of them are still there, but you also lose like your methods, you lose all those things. So again, it comes down to if the data that the JSON gives you is usable for what you're doing, then go ahead and use it. It's however you want to do it, that's fine. There's multiple ways to do it. I just found for me, I don't want to have to basically rewrite my code every time I want a different property or to use a different method each time. If I can get the full object back across processes, I'm going to do it. So you can do that. So that's just a temporary file, out there. Again, you got to make sure you clean it up at the end. You got to make sure you're not colliding with names if you're doing it into a shared directory. It can get annoying. The other method you could use that Microsoft makes available for you is a memory mapped file. A memory map file is available through .NET and .NET Core, and it allows you to create a spot in RAM to basically write to it like a text file. And when you write to it like a text file, it has a few things to keep in mind. Now, map memory files can be either be persistent, whereas they will map to an actual file on your hard drive as well, so you can dump your data out to it and keep it across sessions, or it can be just non-persistent. It just sticks in RAM as long as that computer is around or until you run the command to remove it. There is a module out there of Posh internals that makes working with these mapped memory files pretty easy. So you just import that module. You don't have to worry about too much about the underlying .NET code with it. So again, it's pretty simple to run here. I'm not going to remove it yet. So it acts just like a temporary file. So you, whoop. One second here. For whatever reason, my demo environment today decided that it wanted to stop importing modules on its own for PowerShell Core. So there we go. Okay, so memory file. And I'm going to open the memory file here, memory map file. And the name of this is memory file, just memory file. Now I'm going to read memory map file. So it was able to pull, again, across processes, just that simple amount of text. Notice, text. We're back to that same issue as before, where we can pull and extract text, but we can't do objects. We'll get to that in a second here, but that's becoming more of an issue as we go on. So I'm going to go ahead and remove that. So we can, so let's say we try to do an object. My process data, which is my array of processes again. I just ran that here, and I get, it can't convert it. You know, because PowerShell by default is going to try to do what it can. It's looking at this and it's like, I can't convert this object. So again, because we're dealing with that with just strings. So if we use outstring, just to show what we get here. Again, we get our list of processes, just as we would expect before. And if I pull this open in Core, we would get our list of processes over there as well. We can just pull them back and forth. Again, though, just as strings. Again, because think of this as just a text file that sits there in your RAM. That being said, we can use objects. And here's how we can do it. I have a helper function here, and I'll open this up while this runs here. That takes the serialized code and converts it into a base 64 string for us. So since we can work with text files and strings in these temporary methods in this mapped data file, since we're using a base 64 string, which is able to then, is the base 64 version of our serialized data, we're then able to take that back through the reverse process, take that from base 64 back and reserialize it, and we have our object again transported over that. So what we're doing here, so we have our input object here, and this input object in this case is our list of processes. We're serializing it, which basically means we're turning it into CLI XML in RAM. We're not using any temporary files, putting it out to disk anywhere. And then this next part here, I'm turning it into a byte array. Now, one thing I will say, if you try to do this, the encoding that you choose needs to be consistent throughout the entire process. You can usually get away with going from UTF-8 to ASCII, but if you try to go anywhere to like Unicode anywhere and you're not using Unicode through the whole way, you're going to get bad data. Your scripts will fail. You'll get, I can't convert from base 64. I don't know what I'm doing. And then that converts that to a base 64 string. And base64 strings are kind of ugly. No one likes looking at them. Now, because of what I'll be doing in the next segment here with named network pipes, I'm actually then taking this base64 string I'm creating and then using gzip to compress that string in RAM. So that way it greatly reduces the length, the number of characters that it has to pass through that network pipe or that it has to write down to file. So that way we're going, and we'll show you how good this base64 compression can get here. Usually it's on the order of magnitude of like 87% compression rate. And then it just converts that byte array, that is created through the compression and converts that to another base64 string. So it adds a little bulk back to it and returns that back to the caller. So by doing that, that's kind of that output we get. It's kind of ugly. No one, you look at that in your log, you get those for like through encoded commands and that, and just, yeah, we can convert them back and everything. It's just annoying. You don't want to have to use them. So, I'll remove that memory file. Of course, we can convert that back, that base64 that we just had here, back into a full object. And this object now, because it's been serialized and went through the whole process to text and back, we now have a full object that we can dive deep into again. We have our methods, we have all of our properties, we have all of our sub-properties, just with text. So let me run this here. This will just show you kind of why I'm compressing the strings, because you do get a substantial saving with your data here. So, whoop. All right. So for an uncompressed string, so what I'm doing is I'm grabbing the amount of RAM in use before any operation runs and then after the operation runs. So it's an approximate amount. So for that uncompressed string, it's about 3 megs, a little under. But when I'm running the compression, it's down to 150K. That's a decent, here's our length of our original string, 583,000 characters. After compression, it's only down to 77,000. That's a savings about 86% in this case. I'll take it, especially if you have to save that out to a text file or if you have to send that over the network. That could be a substantial saving, 3 megs versus 150K. Yeah, exactly. It makes my life a lot easier. And especially with, if you're using named network pipes, I've found, especially when transmitting text, can sometimes be a little bit slow, especially if there's any interruptions in their network. And you can have some moments where you're just sitting there twiddling your thumbs away for the data to process back and forth. Now, there is a couple downsides about memory map files. The first one being, you have to kind of predict the future. You need to determine how big to make this. If you choose too small of a size, and you're trying to do this, unlike a text file, what's going to happen is it's going to complain. What I just tried to write to that memory file is beyond its capacity, and it goes, I can't do anything. In its defense, it at least will take what it can and throw that in there. So it got part of the string. Not all, part. I'll take it. But if you were trying to write a base64 string, let's say, for your encoded object, you would get none of your object done because your entire string isn't there. Now, if you guessed too wrong on the large side, and this will probably crash my VS Code, so let's see here. Let me pull up Task Manager first here. You can watch the RAM usage just grow. Let me remove that other disk. And yep, I over allocated the RAM for that disk, and so when I tried to write something, even though it was smaller than the amount of disk that I had allocated, it was trying to allocate that entire file into RAM. So you got to kind of read the future a little bit. How big will I need? You go too big, crash your computer. You go too small, you're not going to get your data out there. So kind of an annoying thing, because it may or may not work out for you. So let me relaunch this here. All right.
So it's also the back of your
Yeah. Mm-hmm.
That's just the same as doing a CLI.
Right. And, but yeah, CLI XML does it to a file. This is just doing it all in RAM. So I'm not actually throwing it out to a file anywhere. So that's why I'm doing it this way. I don't have to worry about dealing with files anywhere. And because I'm doing that, this is now where I can do this next part, which is the named network pipes. And this is, if you want to do inter-process communication, I found this is probably the simplest and easiest way to do it. It's available .NET, .NET Core. And what you need is you have two components. You have your server component and your client component. So your server is going to send the data out to connect for other computers to connect. And multiple computers, multiple clients can connect to the same server. So how they know what they're doing is this pipe name right here is the name. So you could have a computer set up with multiple pipes, servers set up, and it will only answer and connect to the other ones that have the same pipe name. Now, with network pipes, you can also do ACL around it. So you can do security around it. And if you're doing this in production environment, that's the best thing to do. You don't want just anyone to be able to do these pipes. You want to secure everything, prevent any data leak. Chances of the names being the same, especially if you're doing like GUIDs, are pretty low, but you never want to take that chance anyway. So what I have here, what this pipe is, this server component is going to do, it's going to spin up a named network pipe. And then it's going to sit there and wait for something to connect to it. After it connects, it's going to spin up a stream writer, which is then going to take that a script block. And this script block can be as simple or as complex as you want it. I've had entire programs run underneath this that generate their own named network pipes that run within it, that named network pipe. So you can do that. And what this is going to do is this is going to take the result, an object, whatever you pass back through that pipeline, convert it to base 64 string, so like I was showing earlier, and then write that over the named network pipe to the receiver, allowing you to essentially send that data directly to your other process. So I'm going to go ahead and run this over here. So this is a Server 2016 domain controller core running PowerShell core 6.2. All right, so it's waiting for a connection right now. Oh, yep, thank you. All right, so both sides ran. So I'm just going to finish up the dispose here. So on my server 2016 here, it finished running, it disposed of the streams and everything after it did that. And then on my Windows 10 client here, oh, I forgot to load my support thing here, 1 second, after I had to. It's okay. There we go. It would help if I actually ran it, not just. All right, there we go. So now what I have now is a full object of processes from my Server 2016 box. And it's not just a list of texts. If I spell right, everything will go better. There we go. Yeah, I get all my methods. I got everything back over. So then using this method then, I can put this in an executable that runs as a service account. I can put this on another computer if I need to. I've used it at my work to get around them disabling WinRM because I'm able to send data back and forth between computers. Using the base64 process, being able to convert to and from objects is pretty useful. So what I have here, and I apologize if you can't read it, I'll paste the output into a text file because for a reason, my latest update decided to shrink everything. So what this is just a simple executable. What it's going to do is it's going to reach out to my domain controller and try to restart the spooler. And obviously, let me pull this up in a notepad here. It can't do that because my account that I'm running at right now is just a domain user, has no account access other than that in the domain. Standard, basic user. Now if I switch over to this child exe process, and when I have that, all it's doing is spinning up an executable, and I just have it sleeping right now so that way you can kind of see what it's throwing out there. Its input with the pipe name and then what service it's killing, and then this is the data that's sending back over the pipe. And now if I do grab this, I should have a success message, the computer that initiated it, and then what the pipe name was that it sent that data over. So without me having to do much extra work, I was able to get that data back and forth even though they're running under separate logins. So, nope, don't save that. So where this gets even more fun then, especially if you have a packaged executable, is most packaged executables only take string as input. You can't do much more than that. You can give it maybe a short little bit of string and okay, that's great, but what if you want to give it an object? What if you want to give it a custom object you're creating with a bunch of properties and that? You can use base64 as well in there to do the same sort of thing. Pass in that base64 string as the parameter, and then within your executable, take that base64 string, remake it into an object, and then run through all your properties. So for like Sapiens utility and that, I do that all the time on that. Oh, I thought you were raising your hand on something. I was like, what? Yep. There we go. So, whoop. Of course. Thank you, PowerPoint. I never said PowerPoint was part of my job, so. System engineering is, yeah, you could do that if, So again, the temporary files, you need to kind of manage those files. You need to deal about names, clean up collision, don't want to deal with that. Memory mapped, you need to kind of read that future again. You can't go too high, can't go too low, especially if it's on a production system that might impact others. Network pipes, named. So the named ones, there's named and anonymous pipes. The named ones are the network capable ones. Anonymous pipes are only available on the same computer, and they cannot go over the network. So I do have some additional links, and I don't know why they all came up as individual ones, from Microsoft on how you can read a little bit more on named network pipes, anonymous network pipes, and how to use them for inter-process communication. They have their examples that they have are in C#, but again, you don't need to be a developer and use C# all the way to get the benefit of some of this in your own stuff that you're using. So let me pull this up here. My computer is whining like crazy up here, so give it a moment to pull everything up. Is that, okay, that looks big enough. Big enough, yep. All right. So just kind of show you what it looks like in an actual script, not just some demo script that you're running in 2 different shells when you're doing this from an executable here. So again, I'm using base64 to encode another executable within my own executable. Security would probably kill me if they caught me doing this, but instead of having to deliver 2 files, I just deliver 1, let it handle that, I don't care. So what I'm doing here, and this is where I was getting to where you can do this kind of to help your other executables. I have an object here. In this object, I have service, pipe name, because these are 2 pieces of data that I need my other executable to run. And I'm converting that, again, familiar command here, convert to base64 string from object, seeing that one over and over again. And then I'm starting my process of my I call it demo service killer. And my argument list is just that one simple string. And by doing that, then I'm able to do I can talk English. I can then use that to run my other script here. And 1 second, I thought I had it open, but apparently I didn't, So on the child process end, I'm literally taking that command line. For Sapien, it's command line is the parameter that's used. For PowerShell Pro Tools, I think it's command line as well, off the top of my head as well, if I remember right. The only thing you need to do, gotta remember, is you gotta strip off some double quotations, which not that big a deal, but if you forget to, you're not gonna have any data. And then you're gonna sit there and be like, I know I'm passing this, right? Why isn't it working? That allows you to then create your objects from this. So notice I have input object.pipe name, an object that I'm used to working with again. I don't have to go and create all these little random parameters and objects, especially if you go through Sapien's blog on how to do that sometimes. And it makes it simpler for me, at least. So you do that, and that's how you're able to move data into an executable without going through the pipe as well, by using base64 strings as well. So you're able to get data in, you're able to get it out, get it between 2 processes that are running at the same time, and if you use other methods, you can do it even when those processes close. So that's kind of where we're at with that. If there are any questions, comments. All right, so yeah, it's 1:45. You're good? Thank you.